So we now will discuss the properties of the UTXO and the account-based models, right? So there are certain advantages when we deal with the UTXO models. It is easy to verify, and basically all these transactions are processed parallelly. So if there's a transaction happening from A to B, B to C, D to F, uh, X to Y, all these transactions happens parallelly, because all these time the new like two or more new UTXOs are created for any amount of Bitcoin being sent, right? If there's a change required. With the So it is also easy to verify. It provides you with a better privacy, because you can actually, for every transaction, you can actually go ahead and find out where those broken UTXOs are going. So for one UTXO, if there are two UTXOs created for a transaction where either it is a change which is coming back to the one who's sending it, or it is going to a new recipient, you can always try to verify it from one UTXO going and dividing into multiple UTXOs. So it is one of the advantages that UTXO model brings on the table. Um, Account based model, it basically, I told you about the state transitioning machine. It maintains the balance. It works exactly as your bank account. It update account balance directly. Each account will have non-balance code storage. This is what which is being stored on the account. So Bitcoin block and the Ethereum block are very different. Ethereum block, earlier it was again using POW. Nowadays it use POS. So far, what we have discussed about is POW, proof of work. Now, proof of work itself will have, it has many different identities to it. It is used in multiple ways. So earlier, Ethereum was also using POW, which was very much similar to Bitcoin, but it has its own differences with the one used with the Bitcoin. Slowly, the Ethereum was transitioned into the proof of stake. Now, these are the consensus mechanism. We will be getting to know about this later on. Advantage for using the account-based model: it is simpler for the smart contracts. Smart contracts, as we discussed yesterday, are the custom logics which are deployed on top of a blockchain network, which can help the businesses or individuals to basically uh, run softwares or applications for their convenience, right? And it basically brings less data to manage, because in case of UTXO, what happens is that every time you're making a transaction, multiple UTXOs are created. That doesn't happen in account-based model, as it basically does not create multiple accounts or multiple models for every transaction that is being taken place on Ethereum, right? So you can simply see how the transaction flow happens. If A is sending to Ethereum to B, while initial balance of A is 5 Ethereum, initial balance of B is 2 Ethereum. It is simply deducted from A's wallet and sent to the wallet of B. So A will have 3 Ethereum and B will have 4 Ethereum. This is the state after the transaction. So on the right, you can see the state before transaction, and on the bottom, you see it says the state after transaction. And this is what Ethereum brings on the core. It basically is the state transitioning machine for every transaction that takes place on the network. Right. So features, UTXO model and account model. So data structure for the UTXO model is basically depends on the output that you get for every transaction. For the similar example, when you have a UTXO of 3 Bitcoin and you're trying to send 2.5 Bitcoins, the transaction output for 3 Bitcoin will be 2.5 Bitcoin, and the zero point 0.5 Bitcoin. Each of these amount will then be having their own UTXO. The 2.5 UTXO will go to the recipient of that transaction. Zero point 0.5, which is the change, will come back to the sender of the transaction. So this basically works. The data structure is basically involved of the output in the transaction, which is being created in form of newer UTXOs. In case of Ethereum, it is because it is the account state. As I said, that the state of a transaction, a state of the network before a transaction happens, and state of the network after the transaction happens. The amount is directly deducted from a wallet and then sent to different wallet. And then when the amount is updated, it is basically a newer state. And when the amount is not updated, it is the state before the transaction is implemented. Privacy, this basically is being talked about in the solution. Ethereum does have the account state, but it does have a similar sort of privacy. It does tell us that the UTXO model has higher privacy, but it is not always true. There were some shortcomings with the account models, which has been rectified for now. But you have to understand that where this the privacy comes into the picture. So UTXO model, that transaction happens parallelly. So it is always easy in order to rectify or find out things using the UTXOs. And from the UTXOs itself, you will be able to, whenever you're looking into the transaction from the UTXOs, you will be able to check where the new UTXOs are created and where they are going. Uh, in case of account model, which is there with the Ethereum, we will have to basically track the addresses, from which address where the amount is going, and from there where certain amount is going, because it does not create multiple models for a single transaction. For smart contracts, so Bitcoin initially, Bitcoin network did not have any provision for writing any smart contract on top of it. However, there have been forks. We will again, forking is something which is another native term for blockchain technology. We can always take a blockchain network code and then write some new things on top of it, and then try to basically create a new network. Or we can have some provisions into the blockchain network while we are basically creating a new blockchain. We can have some provisions for the upgrades on that blockchain network in future. That also is called fork. There are two types of forking: soft forking, hard forking. These all things we will be discussing in future. But initially, Bitcoin did not have any provision for writing smart contracts on top of it. Ethereum specifically was designed in order to make sure that smart contracts can be made possible. Smart contract is basically, as I said, the custom functionalities written for creating any application or software on top of a blockchain network, Ethereum blockchain. The language which is used, you might have heard about different languages like C, C++, Java, JavaScript, Python. The language which is used for writing smart contracts on Ethereum is known as Solidity, right? It is the one of most famous language, Solidity, because it allows you to write smart contracts on Ethereum. The another famous smart contract based blockchain is Solana, and for Solana the language used is known as Rust, just for the random information, right? So Solidity and Rust are the most common and most trending languages which are being learned in the blockchain space. Now, for the blockchain developers. Now, verification, as I said, that for the UTXO model, the verification has to be done parallelly. The transactions, when happening, in order to make sure that the amounts sent are divided into multiple uh, cash models or multiple UTXOs, as we call it. We will have to track it in a parallel way so that we know how the divisions are happening in the amount, right? However, in case of Ethereum, because you have straightforward deduction from the amount and the rest of the amount stays in the wallet, the amount sent to the recipient goes into the recipient wallet, it is very much sequential to figure out or verify these transactions. Now, storage model. So again, UTXO, it basically is stateless. It basically stays in form of UTXOs. As I gave you the example, you can always imagine as the a cash bill. If it is 100 Bitcoin UTXO, if it is a 50 Bitcoin UTXO, these are basically the outputs of the transaction, and it does not associate itself with any state. It is only mapped with which wallet it is available with, and it does not have any state in that manner. However, in case of Ethereum, as I told you, it is a state transitioning machine. The amount always is associated in a state with the account wallet. So if there's a transaction made from a peer A to a peer B, the state of the entire blockchain network will change, right? And again, when we get into the blocks of the Ethereum and how the verification and mining happens on Ethereum, we will get to understand this in a more detailed manner. Uh, Okay, so we have the difference between public, private, and consortium networks. So access, in case of public blockchain, as we discussed, the access is open. Anybody, the general public, can come and join the network. In private, it is only restricted to the stakeholders of the network. In consortium, it is limited group. So you can decide who can actually look into the network, who cannot look into the network. Some part of the network can be made public. Some part of the network cannot be made public. So all those things are there. Speed in public blockchain is obviously very slow because there's a lot of individual active participants on the network who are all basically communicating on the same network. It makes it very slow because of the increased number of active participants. In case of private, because there are very less number of stakeholders, there are very less numbers of participants, and it is obviously very faster because the communication happens faster because of the less number of individuals talking on the network, communicating on the network. Consortium, because it is a combination of both, we can obviously assume it is medium, because it is slower than the private and it is faster than the public. Consensus, in public blockchain it is decentralized. In private blockchain, again, it says that it is centralized in private blockchain, but you have to realize that in a private blockchain network also, there are different stakeholders, the network stakeholders, and each of these network stakeholders will be having their own uh, devices, and there will not be just one stakeholder making decisions on the data, or there will not be only one stakeholder who is initiating or implementing the transaction. It can be decided in the rules, so it can be centralized or decentralized. It is semi-centralized, I would say, in private blockchain as well. It is same in the consortium blockchain because again, there are private entities involved in the consortium blockchain as well. Example again, for the public is Bitcoin and Ethereum. For the private is Hyperledger, Fabric, and for consortium you have Quorum or the Corda, Arti Corda. Um, so this is it. We will now get to the summary. Blockchain, I believe you now know, is a secure, immutable ledger. It is secure because the validation can only be done making sure that the hashes matches, and any change on any transaction basically change the value of the hash. And while we validate the transactions on the network using the hashes, it is very evidently visible that there's a change made in the transaction if the hash is changed, and then the transaction is not put into a block. So it is very much secure. It is immutable because again, you cannot change anything, because if any information you change, the hash will change. Key elements is hashing consensus mechanism. The consensus mechanism is something that we discussed, POW or POS. Decentralization, of course, because there are different peers from different parts of the world who are keeping the storage of the data. Then there are some other key elements, the public-private key, how you are able to have your digital ID on the internet, through which you can join the network as somebody who wants to transact, or as somebody who wants to participate as a miner, or as somebody who wants to put a smart contract on Ethereum blockchain. So those are the key elements. You know the types of the blockchain as well, the public, private, and the consortium blockchain network. You know the two models of how a transaction is being sent in order to stop the double spending. You know the use cases in you know that the use cases expands till the domain for the finance, identity, logistics, healthcare, etc., etc. Mostly in the supply chain, there are multiple industries in supply chain spaces where this is being used as well.